Thanks everyone for joining the second Db2 session today. And this is all about query transformation, how Db2 transforms customer SQL queries and optimizes them for CPU use and reducing elapsed times. So today I'm excited to say we've got Huang Tran who is a lead developer for Db2 ZOS in query semantic transformation IBM. So the leading expert from IBM on the subject. So this should be a really good session. So I'm glad everybody's turning up. Please do remember to contribute to the good causes that GSE is supporting this year, which is the lifeboats and the guide dogs for the blind. There is a charity raffle. So once you've contributed, you can enter that raffle with your contribution and get a certain number of tickets for the raffle. At the end, please do fill in your feedback forms. This is session 2A0, and put down the scores so that we can improve for next time. I don't think there's much more to say, and please enjoy. Sit back and enjoy. Huang Tran, over to you.
Okay, so my name is Huang Tran. I am one of the developers for Db2Z at IBM. And today, the topic of the section today is query transformation in Db2Z. So what is query transformation? Db2Z has many phases for query transformation. The first phase, the SQL statement had to go through is the parser. So the parser job is to validate the syntax. After the syntax is validated, this semantic checking will be done, and the query transformation phase is following. So what is the purpose of query transformation? The query transformation, the purpose is to transform a query in such a way that it will be logically equivalent to the original query, but yield a much faster execution time. As we seen today, some of the queries are not written with optimization in mind. Some of the queries are generated by the tools or by application. Those queries are often very complex and contain many nested levels of subquery. For those queries, transformation are needed to improve the performance. So what kind of performance transformation, query transformation that Db2Z offer? Db2Z has many different types of query transformation. Today, I will go over predicate transformation in Db2Z. Under predicate transformation, we have predicate pushdown, predicate bubble-up, predicate transitive closure predicate, transformation from English between predicate to equal predicate, transformation of all predicate to English predicate, and predicate simplification. We also have joint transformation. Under joint transformations, I will discuss the subquery to joint transformation and outer joint transformation. Next is a view and table expression transformation. We will go over view, merge, and table expression merge. Last but not least is the union transformation. Under union transformation, we will discuss subselect pruning and union distribution. So before we start discussing about the predicate transformation, there are some terminology that I would like to go over. These terminology are used throughout the presentation. So the first terminology is the predicate types. The predicate could be either a simple or a compound predicate. A compound predicate is the result of two predicates and joined together by an AND or an OR condition. In the example, we have two symbol predicates that are joined together by an AND condition. The simple predicate is a single term predicate. Another terminology is the predicate can be either local or joint predicate. Local predicates reference a single table, as we show in the example. The first example, the predicate reference to a column C1 from table T1. The second example, the predicate references to two columns from the same table. Joint predicate are predicates that reference more than one table, or it could be a correlated reference. The first example, we see the predicate reference two columns from different two tables. The next example show a substring build function reference two columns from two different tables. A predicate can be either a Boolean term or a non-Boolean term predicate. So a Boolean term predicate that are predicates that are not contained in a compound or a condition. In a Boolean term predicate, if one of the simple predicate is evaluated to false, the whole predicate will be evaluated to false. For example, in this compound predicate, they are joined together by an and condition. If one of the simple predicate is evaluated to false, and the whole predicate will be evaluated to false. Non-Boolean term predicate are predicate joined together by an or condition. Now let's talk about the predicate transformation. The first category that we're gonna cover today is predicate pushdown. So what is the purpose of predicate pushdown? Predicate pushdown is trying to push the predicate from the outer code block to the table expression. The purpose is to add more filtering to the table expression in order for us to reduce the table expression work file size. In this example, we can see that we have a table expression QTR underscore cells. This table expression has no filtering, so its work file size could be large. We have a query block. We have a predicate on the outer query block. If this predicate is pushed inside the table expression will have more filtering and its size could be reduced. Db2 support different predicate types for predicate pushdown. The predicate had to be in the form of column compared with a literal. The comparison operator can be equal, not equal, greater than, less than, or equal, or greater than, or equal. The predicate can be a like predicate or not like. The predicate can be a not between or between, and the higher bound and the lower bound had to be a literal constant. The column is no or is not no, or the predicate can be an English predicate. In the cases that Db2 does not support predicate pushdown, some cases manually pushdown predicate is recommended. So what are the cases that we recommend manually pushdown predicate? If the predicate refer to a materialized view or a table expression, and the predicate is a compound predicate, the predicate is a joint predicate, or the subquery's predicate depend on materialization. In these cases, manually pushdown predicates is recommended. Here we show some example how to manually push down the predicate. In this example, Db2z will not push down this predicate into the table expression because it is a compound predicate. So if the predicate is manually pushed down inside the table expression will have filtering and the size of the work file could be reduced. Predicate Bubble-Up. We just talked about the predicate pushdown. So predicate pushdown is trying to push the predicate from the outer query block to the table expression. Predicate Bubble-Up is for correlated subquery and is trying to pull the predicate from the subquery to the outer query block. In this example, we have a axis subquery predicate, and there is no local filtering on the outer table, which is T1. We have a correlated predicate, and we have the local predicate on table T2.ssn. In this example, the subquery is dependent on table T1. From the predicate inside the table expression, Db2 generate another predicate, T1.ss1 equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. This predicate is then replicated and pulled out from the subquery. So now the outer query block will have filtering. So T1 now has a local predicate on column SSN. The next topic of predicate transformation is transitive closure predicate. The purpose of transitive closure predicate is to generate additional predicate. These predicates are allow us to have more choices, more joint condition choices. These more joint condition will be allow us to choose maybe choosing a better joint permutation, a better access path. In this example, we have two predicate T0.C0 equal to x.C1 and T0.C0 greater than 100. This is before the transformation. After the transformation, we have an extra predicate x.C1 greater than 100. And this predicate from the outer query block can now be pushed inside the table expression. So it possible can reduce the size of the table expression work file. Transitive closure are supported only for local predicates. The syntax is the column compare with a literal. The comparison operator can be equal, not equal, greater than, less than, smaller than and equal, or greater than or equal. The column can compare in the between predicate or not between predicate, or is an English predicate. Transitive closure are not supported for all predicates, like glide predicate, column in a non-correlated subquery, or a compound predicate. These cases, Db2 does not support transitive closure. In transitive predicate, transitive closure can be applied to both local and joint predicates. The first example we see here is Db2 generate a local predicate. This new predicate allow additional filtering on table T2. The new predicate is T2.C1 equal to 30. Db2 also can generate a transitive closure for joint predicate. This will create an additional joint sequence. In this example, a new predicate is generated, T1.C1 equal to T3.C1. Transitive closure is not performed on all predicates, as we already mentioned, like glide predicate in non-correlated subquery, we don't generate. In this example, we can see there's are 3 predicate for on T1 in the blue color. From these 3 T1 predicate in blue, we can generate additional predicate for table T3. But in this case, it's not being done because The cost could be expensive, and it may not lead to a faster access path. Why these predicates are not transformed? The live predicate cannot transform because live predicate can eliminate previous index-only access. The English or compound predicates are not transformed because the cost to look into compound predicates cases are expensive. English predicate will not be transformed because if the English contains a large number of entries, the cost and to look into each entry and generate additional predicate for English are expensive. And sometimes it could cause SQL code minus 101. SQL code minus 101 is issued when the Db2 runs out of storage or its internal data structure size is exceeding the limit. So if the English contains a huge number of entries, generate duplicate new predicate can cause SQL code minus 101. The column in subquery, we don't transform the cases when the predicate contains a column in subquery, because in this case, additional predicate would cause the subquery to be executed twice. So therefore, more research are needed to extend transitive closure. The recommendation for transitive closure. So in the cases that Db2 does not perform transitive closure, consider manually adding predicate. Adding these predicate will increase the optimization opportunity, and this opportunity may be allow us to choose a more efficient access path. Db2 also transform all predicate to English. In this example, if we have column C1 joined together with an OR condition on the same column, this predicate is rewritten as C1 in 1, 2, 3. This transformation is performed because now the column becomes a candidate for a single column English access. Db2 also transforms the English or between predicate to equal predicate. The first example shows English is transformed to equal. If we have a predicate C1 in an English and the English just contains one entry, the predicate will be rewritten as C1 equal to 1. The second example shows the between is transformed to an equal. If C1 is between 1 and 1, so in the case when we have the upper bound and the lower bound are the same, the predicate will be transformed to an equal predicate. These transformations are performed because in and between are not candidates for the predicate transitive closure transformation. More statistics are usable for the equal predicate, and between and English can start matching index earlier. The next topic is predicate simplification. The predicate simplification is a way that Db2 transforms a query that contains a predicate with years, date, and structure built-in function. These built-in functions could be removed from the predicate for a better performance. So in the case of the year built-in function, if the input argument of the year built-in function is date, timestamp, or timestamp with time zone, and the value is an integer, the predicate can have the year built-in function removed. In the case of the date function, if the input argument to the date function is a column and the types of this column is timestamp or timestamp with time zone, and the value is a day, char, or varchar, the date function may be removed. the substruct built-in function. If the input argument to the substruct function is a char, varchar, graphic, or var graphic, and the value has the same data type and CSS ID as the column, the substruct function may be removed. The comparison operation can be equal, greater than equal, smaller than equal. And the values can be a constant, a variable, or any invariant expression. Invariant expressions are expressions do not change during statement evaluation. So here are some examples of invariant and variant expression. Invariant expression contain a constant or a constant expression. Like the first example is a single constant. The second one is a constant expression. And the third example is an expression with a special register. And the last example is a host variable. Example of variant expression. Variant expression that are expression that could change during execution. The expression variant expression contain a column, a built-in function, or a random function, or it could be a user-defined function with external action, and it is non-deterministic or modifies SQL data. Here are some examples on how do we transform statements that contain predicate with year, date, and substruct built-in function. The first example, we have a year function on a column equal to 2012. If the column type is date, and if there is index on expression exists on the year column, then Db2 generate a new predicate of between. The constant 2012 is changed to a date format, and the range is the beginning of the year 2012, and the upper bound is the end of year 2012. Since there is index on expression that exists on the year column, this year function will be kept. If the column is timestamp, then Db2 change the constant 2012 to 2 timestamp constant. And if there is no index on expression on the year column, then this year function will be removed. The second example shows the date function. The date function compared with a varchar. If the input argument is a column of type timestamp, and if there is index on expression exists on the date function, then Db2 generate additional column, additional predicate. The new predicate is a between, and the varchar constant will change to a timestamp constant. And since there's index on expression on the date function will be kept. Another example shows the substruct function. In this case, if the column is a varchar 10 Unicode, then Db2 will add a new predicate between, and the constant will be changed to Unicode constant and will be padded with 0 and FFF. In predicate simplification, the different comparison operator produce different transformation. For example, if we have the year function compared with greater than 2011, if the column is date, then the function, the constant 2011 will be rewritten as a date, and the date is the end of the year 2011. If the operator is greater than equal 2011, then the constant will be changed to a date, and the value is beginning of 2011. The next example is we have a between. two constant 2000 and 2012. If the column is date, then a new predicate between will be generated. And we have the upper bound and the lower bound. The lower bound will be beginning of the 2000, year 2000, and the upper bound is the end of 2012. Another example is we have the year function in the in predicate. In this case, is the two constant in 2011 and 2012. In this case, Db2 will generate a compound predicate, two between joined together with a or condition, and the constant will be changed to a date format. So to summarize the predicate simplification, Db2 generate additional predicate for the cases that predicate contain a year function, a date function, and a subtract function. If there's index on expression exists on the left-hand side expression that contain the year, date, and subtract function, then the original predicate is left in the query. If there's no index on expression exists on these built-in function, then the original predicate will be removed. When is this transformation not done? If the predicate contain the year, the day, and subtract function is in the having predicate, if it's in the case when clause predicate, if it's an on predicate, and if the column is from the preserved side of the outer join, or is in the line predicate, or if the value is a variant expression, these cases Db2 will not do the transformation. Next, we can jump to joint transformation. In the joint transformation, we have two categories: subquery to joint formation and outer joint transformation. Subquery transformation. What is the purpose of subquery transformation? For a SQL statement that contains a subquery, it has an implied sequence, execution sequence. If this subquery, if this type of statement can be transformed to a join, additional join sequences and method can be considered. The subquery transformation can be applied to both correlated and non-correlated in subquery. If the statement contains multiple subquery, we will have a multiple select blocks. Subquery transformation is trying to merge these multiple select query block into a single query block. Here are some examples of subquery to joint transformation. In this example, it's showing the statement have an in subquery predicate. After the transformation, the table inside the subquery predicate department is joining with the outer table EMP. So in this case, you can see now we have additional join sequence. In this case, for Db2 to transform this subquery into a join, there are certain conditions had to be satisfied. In order for the new statement to be logically equivalent to the original statement, the department number values must be unique. So in this case, the unique index had to be defined for the department number column. The second example we show, we transform correlated subquery using in predicate to a join. So in this case, we can see we have an in subquery predicate. This predicate is a non-correlated subquery. So after this predicate is transformed into a join, now we can see we have more additional join sequence. There are certain conditions that must be met in order for Db2 to consider subquery to joint transformation. The conditions are the set comparison predicate can be in, equal any, equal some, or exists. No column function can be in the subquery. The subquery has to contain a single table. The subquery does not contain any goodbye or having clause. For the non-correlated subquery, there cannot be any duplicate returned from the subquery. This because this is enforced due to the semantic of the in keyword in order for us to guarantee the same result. This list is not complete. For complete list, we have the documentation in the Db2 administration guide. The section is titled Condition for Db2 to transform a subquery into a join. Please see this list for more detail. There are some consideration for correlated subquery. How can you influence when a correlated subquery will be evaluated? Usually, a correlated subquery will be evaluated when all dependent tables are in the composite. So when the subquery is called, it can be called against a single table or a set of tables. How you code the subquery will influence when it is evaluated. So here are some examples how to code the subquery so it can achieve a better performance. So in this example, we can see this subquery only depends on table T1. We have a join predicate between T1 and T2, and we have an equal subquery predicate on T1, and inside the subquery, we have another predicate also depend on T1. So in this example, the subquery is only dependent on table T1. The same query can be rewrite into an equivalent query. In this example, since we have a join predicate between T1.C2 and T2.C2, this predicate can be changed to T2.C2. So now this subquery is depend on table T2. The next example shows the same statement can be rewritten, so it depends on table T1 and T2. We have a predicate T2.C2 equal to a subquery, and inside the subquery predicate, there's a predicate on T1.C1. So this example shows we can write the same query that depend on both table T1 and T2. So what differences does it make? How to write the subquery so it can achieve a better performance? If the subquery predicate is cheap and is highly selective, and our goal is to evaluate the subquery as early as possible, so it should be coded against the likely outer table. If the subquery predicate is expensive and it has low selectivity, then our goal is to evaluate the subquery as few times as possible. So it should be coded against more future table. If significant selectivity after join of two tables make the subquery dependent on both tables. There are some filtering and cost consideration for correlated subquery. High filtering estimate can move a table up in a join sequence. Very expensive correlated subquery can push the table to be joined later. Next, we can talk about outer-join transformation. In outer-join transformation, Db2 is trying to transform a full outer join to left outer join. This is done because full outer join is expensive. Full outer join is implemented as a sort merge join, which potentially is an expensive operation. Transforming the query to a left join has the possibility of using a nested loop join, which is a cheaper operation. Db2 also transform a left or right outer join to the inner join. To change the left or right outer join to an inner join allow more sequences and method and more join method that the optimizer can consider. This can also reduce materialization. Here are some examples of how DB2 transform outer join, full outer join to left outer join in this example. In this example, before transformation, we have T1 full outer join with table T2. There's a local predicate on T1.C2 greater than 100. After transformation, the T1 become left join with table T2. In this case, the transformation is possible because we have the local predicate T1.C2 greater than 100. So any T1 node particle will be removed by the where clause. So the full outer join can be safely transformed into a left outer join. In this case, we show an example on how DB2 transform a left outer join to inner join. In this case, the example we show, we have T1 left outer join with table T2. After the transformation, T1 become inner join with table T2. This transformation is possible because in this case, we have the local predicate, and this predicate will remove any node particle from table T2. So the left outer join can be safely transformed to an inner join. The next topic we will go over is view and table. Let's see. View and table expression transformation. In this topic, we will talk about view and table expression merge. The view merge. If we create a view, for example, is the views created as a join of two tables, T1 and T2. When we reference this view, if this view is materialized, we can see we have T1 and T2 would be joined on future. The materialization work file from view V1 could be large. There's no index access on the work file. We have less join sequences and less join method to consider. If this query, if the view in this example can be merged, then we will have more join sequences. And you can see here, now we can have T1 inner join with T2 and inner join with T3. There's more indexes available and possible more join method. Materialization view or table expression is undesirable because we don't have many opportunity for optimization. We have less join sequence to consider, and the chosen sequence may not be optimal. The statistics on the materialized view will not be as accurate as base table. This will cause the optimizer make less accurate access path selection decision. There's no indexes on materialized view, so there are fewer efficient access method, and predicate are not pushed out into materialization. The cost to materialize view are expensive. When we reference the view and the view is materialized, the entire view must be processed before we can retrieve the data from the view. Any materialization involve the base table inside the view being read in, processed, and written back to this. Materialization also can delay finding first row. The user waits longer for fetches to start. Merging table expression is similar to merging the view. In this example, we can see we have a table expression. Before merge table expression, we have the join sequence is the department joined with a table expression. After we merge the table expression, we have additional join sequence. We have the department table and joining with the base table employee. This table is from the table expression. So the view, in summary, the view and table expression merge is very useful because this allows for more join sequences, it eliminates expensive materialization, is avoid predicate pushdown limitation, is allow usage of indexes on base table. Because joint predicate are not pushed out into materialization, and also predicate are not pushed out would not be indexable. Some suggestion how to avoid view and table materialization. One of the suggestions is to avoid view and table expression that use listing and group by. If the view or table expression that use listing and group by, these must be materialized. We push as much filtering into view and table expression as possible, so we can reduce the size of the materialization work file or table expression. You can transform a non-correlated table expression or view into a correlated table expression or view. Here are some examples on how to transform a non-correlated table expression to a correlated table expression. In this example, we have a non-correlated table expression. The original query head is non-correlated table expression, table DX. So without the transformation, the table DX is a full aggregation of the department table. There's no filtering on the department table. The department, the table employee table is substantially reduced with a local predicate. We have a local predicate employee underscore area equal Hawaii. So this employee table will be substantially reduced with this local predicate. This materialization is very expensive because there's no filtering. We can correlate the table employee and table department by doing the following thing. We can add the table clause and adding another correlation predicate. In this case, the query is transformed from a non-correlated table expression to a correlated table expression. The new transformation will have a major improvement when correlation predicate provides much more efficient access to the inner table, and the outer table employee is highly selective, which means the fewer access to department is required. Last but not least, we will talk about the union transformation. Under union transformation, we have two categories. We have subselect pruning and union distribution. Subselect pruning. Subselect pruning is very easily exercised for select statement that link together by union or by union or. The purpose of the subselect pruning is to remove query block that are not return any data. How does Db2 does subselect pruning? Db2 try to comparing the predicate in the nested query block with the parent query block in the parse. When is found any contradictory predicate, we can remove that query block. I can show some example. In this example, we have the view. The view is contained of 4 subselect. They are joined together by a union or. When this view is referenced, we have a predicate on the outer query block. The date is, we want the date is between April 15 and April and May 15. So based on this predicate, we can see that only the second query block is satisfying the current condition. So when the view is composed, we can compare the outer predicate with the nested subselect inside the view, and the unnecessary subselect can be removed. This is very handy because it can reduce the complexity of the view, and it can be also sometimes it can help us to avoid SQL code -101, because we by pruning the unused subselect, we can reduce the data, the storage, or we can reduce the size of the Db2 internal data structure. Distribution is applicable for query contain union or. In distribution, we can distribute predicate, join, and aggregate a function into nested select blocks. In this case, we can see we can have aggregate average function. We have a join department, table join, and we have a predicate. By distribute the table expression into the pen code block, we can allow more opportunity for the table expression to be merged. So this is the original query. After the distribution, you can see this is the query. The table expression is distributed into the query block. So now there's more opportunity for the expression to be merged. So in summary of the query Db2Z query transformation, the query transformation purpose is to transform a query so it can open up as many access path choices as possible. We have many types of transformation in Db2Z, but the one that we are go over today are predicate transformation, the joint transformation, view and table expression transformation, and union transformation. So if this concludes my presentation today, please, if you have any question, please let me know. You have my email. If you need to reach out to me, please drop me an email and I will return your email as soon as possible. Thank you for your support.
Thanks very much, Wang. That is a really good in-depth look at transformation. Crikey, there's a lot of information in there. I've made a few notes, but I think I'll have to go to the replay to take it all in. So it's really, really good. And also, thanks very much for getting up so early in the morning to present this. Really appreciate that. There's just one question on the chat channel from Marcus. He's asking, with the transitive closure, how can we tell whether Db2 has transformed the statement or not, so that we can then rewrite it ourselves if need be?
Db2, you can explain, let's explain table. There, I think the name of the table is DSN underscore predicate statement. So there they would list all the predicate that we, the original plus the new predicate. So from the explain table, we can see the new predicate and the original predicate.
Right, thank you. Does that answer your question, Marcus, or did you want to follow up on that? Ah, good. Marcus says fine. Okay, I was just going to unmute you otherwise, Marcus, but if that's okay, that's good. Anybody for any other questions? Or does everybody want to dash away to lunch? I've got a feeling I know the answer to this one. Okay, well, thanks very much again, especially as it's so early in the morning where you are today. If there are any other questions, we can fire them off to you via email. That's really good. Please fill in the feedback. This is session 2AQ. This is the only way we can improve things, by filling in feedback and improving things for the future. And the next session is coming up for Db2. It's at, I've got it written down somewhere. It is at 2 o'clock. Mark
Okay.
Rader is going into system managed CF structure duplexing and giving us an update on what's happening there. Please support our charities for this year, RNLI and the Guide Dogs for the Blind. Very easy to donate. There's links on the website, and I've actually done it this morning very fast, very quick, very efficient. Okay, well, have a good lunch, everyone. We'll see you all back for the 2 o'clock session. And until then, thanks very much.
Thank you.